Okay, for this practice exercise, what you need to do is to still predict the function or the graph of the function using the value of the discriminant. The value of the discriminant will further tell us later the number of intersections our parabolic graph will have against the x-axis. And it will be further clarified on the next lesson as to what do we call the number of intersections. So for these three different functions here, 1, 2, and 3, we are to determine first the value of the discriminant, and then we're going to determine the number of intersections with the x-axis. Take note that the discriminant is to be solved with this formula, b squared minus 4ac. We use this expression to identify the nature of the roots of a quadratic equation. If the value of the discriminant is greater than 0, then there are two solutions. The nature of the roots are they are both real but unequal to each other. If the value of the discriminant is equal to 0, that would mean we only have one root. The nature of the roots is that they are both real and they are equal. And finally, if the value of the discriminant is less than 0, we don't have a solution or the solution does not exist. This means that the two roots are both imaginary. These concerns could also tell us the number of intersections with the x-axis. The number of intersections with the x-axis corresponds to the number of solutions for each of the following quadratic function. In short, if the value of the discriminant is greater than 0, we have two intersections with the x-axis. If the value of discriminant is equal to 0, we only have one intersection with the x-axis. And finally, if the value of the discriminant is less than 0, we don't have any intersection with regards to the parabolic graph and the x-axis. Of course, that's our first task here, and then later on we are to graph them to verify whether our answers are correct or not. Let's start for number 1. The correct coefficients here, A is 2, B is negative 4, and C is 0. Again, we use the correct identification of coefficients before we could solve for the discriminant. Take note that C is the constant, B is the numerical coefficient of the term with x, and your A is your leading coefficient. So the value of the discriminant here can be computed with this formula. So by simply substituting, you will have the result negative 4 squared minus 4 times 2 times 0. Using this, negative 4 squared is 16 minus the entire expression becomes 0. So the value of this discriminant is 16. 16 is a positive number. Let's place it here. 16. And 16 is also greater than 0. Using the same concepts here, if the discriminant or the value of the discriminant is greater than 0, we expect two roots, and those two roots are also considered to be the number of intersections with the x-axis. In short, the answer here for the number of intersections with the parabolic graph and this and the x-axis would be 2. Again, there are two intersections. Later, we are going to check it using our graph. Let's proceed to number 2. And again, to determine this, by the way, it's here at the bottom, we also need to use the discriminant. The correct coefficients for this function, A is 1, B is negative 6, and C is equal to 10. Using these values, substitute to the discriminant b squared minus 4 ac equals b squared is negative 6 squared minus 4 times 1 times 10. 6 or negative 6 squared is 36 minus 40. The value of the discriminant is negative 4. If we're looking at it as to the nature of the roots, we know that the two roots are both imaginary and hence we don't have any solution. So the value of the discriminant is negative 4, and that concern could also answer the number of intersections with the x-axis. Using this concept here, if it's less than 0, the number of intersections we have with the x-axis is none, or you could simply say 0. Again, we will verify this later on our graphing. Let's finish this prediction using the discriminant for number 3. So the discriminant again will use the coefficients. A here is 1, B is negative 2, and you have the coefficient C, which is 1. The discriminant is B squared minus 4 AC. And when you substitute them, you have negative 2 squared minus 4 times 1 times 1. Negative 2 squared is 4 minus 4. The result of the discriminant is 0. This is the value of the discriminant. Under quadratic equations, it tells us that the roots are both real and they are equal. Hence, we only have one solution. And this is also true with the number of intersections with the x-axis. So here are the answers for the predictions of the graph in relation to the number of intersections it will have with the x-axis. This is for number 3, number 2, and number 1. We use the discriminant to predict or to give advanced analysis on what would our graph look like.